Just get yourself settled. We're starting like actually right now. So
Yeah. For everybody who just arrived, the board says if you haven't already, please get your OS boxes out and open the Arduino IDE so we can get started really quickly.
you want to give that 2 more?
Two. Okay, I can give like one more minute. Yeah.
Do we have a laser pointer?
I don't think so.
Oh yeah, I forgot about that. We can't delay it too much.
Yeah.
Alright.
Sure.
Okay, guys, we're actually getting started right now. Just we're anticipating the end maybe later today. You guys should probably.
Don't worry, this lecture shouldn't take too long, I think.
It probably won't take too long.
Okay, so first, really quick, just a couple of reminders and stuff. So we have Project 3, iPodWino, of course, that's what's all on our mind right now. So our work session for that is going to be next week on Thursday at 7 p.m., not 6 p.m., reminder. The due date for the iPodWino is going to be Wednesday, the 8th of February at 5 p.m., not 11:59 p.m., 5 p.m., because we're going to have our competition the same day, Wednesday, February 8th at 6 p.m. here in the IEEE lab again. We're going to have food and we're going to have prizes. So, hope to see many of you there. Second announcement. You want to do the announcement?
Okay, so a lot of you may have noticed a magical channel appeared out of thin air. That actually was not supposed to disappear at all. So it's the Ops Announcements channel. That's where our lectures we were supposed to be sending messages about like where it is. Maybe once we opened it back up, you guys got like 20 messages from us or something like that. We didn't send 20 messages at the same time. They were just there, and y'all didn't receive them. So it's fixed now. We still don't know the cause of the problem, but that's Ops Announcements is what we primarily use to let you know where things are, when they are, how it's going to be done, when the project submission is, when you forget the day before you stop. Yeah, that's how we contact things. But yeah, we're sorry about that. It's kind of it's a doozy. It's nothing that we could really fix.
Yeah.
Well, nothing that we knew about actually.
Yeah, until very recently. So, sorry about that. But hopefully, as long as you keep your Discord notifications on, we should be able to contact you through there now. Okay, so now we will actually start getting into the thick of things. So, the way this WorkshOPS is going to work is going to be slightly different from the first one. The first one is mostly just like a lecture, and then we had a little quiz at the end. This one is going to be more of like a project walkthrough. So there's 3 parts to this project. Part 1 is just getting started. Part 2, we're going to add a little bit more onto what we made in part 1, and then there is a bonus part 3, and if you finish that, then we'll give you a little prize. That's like the main layout. So starting with part 1, which is going to be most of our lecture content, getting started.
So we're gonna get started by looking at your Arduino kits. You guys can bring them out. It's not really essential right now.
It is essential.
I guess it is essential.
Get your Arduino Unos out.
Yeah. Alright. Okay, so as an overview, for this project at WorkshOPS, we're going to be dealing with microcontrollers for the Arduino Uno, the GPIO pins, digital analog pins, for output, and as bonus, voltage dividers. Don't worry about that to the last slide. And then materials we'll need for this right now. So get your Arduino Uno out, get your breadboard out, a USB cable that allows you to connect to your computer. If any of you don't have an adapter, like let's say you have a Mac, you USB-C to USB, let me know now so I can get you an adapter. Okay. Also, get your jumper wires, resistors, resistors, 3 buttons. I want to get that butter. You should be able to see that coming.
You can use a small one. It should fit in the small one, but the big one is just like big, so it's nice. But
in the future, if you don't have one already, I would recommend getting one if you have a Mac, or just a computer that only takes USB-C. Get an adapter so you can work it. Or get a USB-C to micro USB port. One might be cheaper than the other, but one's more useful. I feel like I use the adapter.
God, it took so long to pack everything here.
Oh, and then grab out the potentiometer.
Potentiometer is part of the bonus, just
it's part of the
FYI.
bonus. The fan motor is actually really small.
I'll have an
It's
image later.
pretty small.
It's so sad.
It's not the
step
motor.
motor.
It's not the step motor. It's a smaller one. There's two motors.
There will be an image later.
There's a big one and a small one. Grab the small
The other one.
The other
This
one.
Yeah. That's right.
It should come in a little baggie.
That's so weird. Yes.
Alright. Don't need to rush because we still have time going through the lecture. So, but these are all the stuff you're gonna need.
Alright. As you guys are getting that out, I'm going to talk about the brief little overview of it. So, the Arduino Uno we talked about in lecture, what was it, 5?
Mm-hmm.
About, being a microcontroller and kind of the basic functionality of it. But in terms of now, I think that you guys should be able to, at least from the last two lectures, somewhat be able to identify what a digital pin looks like and what a PWM looks like, the analog pins and the ground pins. So as a test of knowledge, I'm going to call them in randomly, and you guys have to tell me what the identifying factor of the specified pin is. So, digital pin. Yeah. If you look at your Arduino, how are you able to identify a digital pin?
Well, it says digital next to it.
Very nice! Yeah! Right. Give him a prize, give him a Welch's.
Oh, yeah.
Do you want fruit snacks?
Sure.
Alright, sweet. Awesome. Okay. Okay. PWM.
Well, there's
Like, how do you identify it? What's the little thing that identifies a PWM?
one that says power.
No.
Dang. Alright.
Try again.
5 volt.
No, it's okay. Does anyone else know?
It says PWM is still digital.
Well, yeah, but there's one thing in particular.
Is it the squiggly line?
Yes. It's called a tilde.
Oh.
I don't know if you can kind of see on the board here, but you can see like over 6 that has a little squiggly line next to it. That means that's a pulse width modulation pin. So you should be able to identify on your board all of the pins in the digital section that are capable of doing pulse width modulation.
Yeah.
Oh.
And then analog pin. Can anyone tell me what well, actually, I'm going to call someone. Alright. What identifies an analog pin? Yeah, let's go.
You got it.
That's sweet.
So just as an extra note, all of the analog pins should have an A in front of them.
Yes.
And that is important when you declare the pins in your code. You need to have the A in there.
So basically, we'll get into that when we get to the coding part. But when you declare a digital pin in Arduino IDE, you just declare the number of the pin. But when you use an analog pin, you have to have this superscript, or not superscript. You have to have the prefix A, capital A, and that lets the processor know that you're using an analog pin. Otherwise, it's going to think that you're referring to like something like digital pin 6 instead of analog pin 6. Okay, and then we'll be using these pins for the project. I think you guys know what the 5-volt, 3-volt pins are at this point. Ground is just G and D. I'm not really going to quiz you on that because we've dealt with that for a while. And then I want you guys to open Arduino IDE right now and plug in your Arduino. Okay? So that's how we're going to get ready. So do that now. You don't have to have anything attached to it. Just plug it into your computer. All right?
Okay.
Alright, so as some concepts for this workshop, we're going to be dealing with the fan motor and pull up, guess what, pull up, pull down systems, right? So pull up, pull down for your buttons. In terms of the fan motor, there's 2 leads. There's your red lead and your black lead, but they mean a lot more than that. So black is your ground, and red is driving power. Actually, we're going to be dealing with different variations of speed for this workshop, so you guys are going to be signaling to the fan to like make it do different things. Actually, wait. Well, you can do it with PWM, but in the case of this workshop, I think we're just having to do it with the buttons and different resistor for voltage dividers. But sorry, in regards to that, to change it, we can based on like lecture and what we taught you, what function, or like, what do we typically use to write a particular voltage level to PWM? Like, what's the function in Arduino IDE that allows us to write a PWM signal? Anyone know? No one? No one else?
It's not digital, right? It is
It's
analog, right?
okay?
Very good.
So you can't analog write from an analog pin because analog pins are only input on your Arduino pin, okay? But you can analog write from a PWM pin, right? Okay. If you try that on a regular digital pin that's not PWM capable, it's probably going to switch. It's only going to alternate between 0 and 1 in the first place, but I don't really know the threshold for that. Some instances it's different, like some processors it's like 33% of what you put in is going to draw a 1, everything else is 0. It might be 50-50. I can't say that. Basically though, just use the PWM for the PWM, okay? And then in terms of pull up and pull down, when we use switches and they're off, right? We use pull up and pull down resistors because we don't want a floating node. We don't want them to be connected to nothing, right? Because if they're connected to nothing, then around CERN, your processor could your Arduino could literally find any value it wants and associate with, and then your buttons is not really gonna work, right? So because of that, we want to eliminate that noise by using pull up and pull down resistors, right? So we usually use a pull up and pull down resistor that's greater than 100 ohms because we need a way for current to flow through without kind of damaging ground. Because there's still a way to short to ground. This is the baseline part of it. But basically, if you short to ground, it's because you don't have enough current limitation to ground, right? Let's say you know how if you back to the water, if you have a hose, you spray really hard on the ground, it might damage the rocks and move them, right? You don't want that to happen. You want it to limit it so that it kind of trickles over, right? So that's how you prevent such it's not really short to ground, but in a way kind of you're preventing an error that could happen, right? Because circuits like the real world all have malleability, an error and stuff, and your component can just get totally trashed. But basically for pull up, it sets it to high, so that's your default. So default open, right?
Yeah.
Yeah. So for your default here, high, it's 1. Okay. So when it's open, it's 1. But when it's pulled down, that's 0. It's your default. So when you press the button, it's 1. If you pull up, if you press the button, it's low. That's really just up to you guys. In that case, application wise, doesn't really matter. It's whatever you feel more comfortable with. I personally am a pull down guy because I'm it makes more sense, one pressing it. But some people really prefer the 0 option.
Okay, so that is pretty much all the hardware that we're going to be using. You have a question?
Is there an issue if you put a lot of work? Can you open field resistance for pull up, pull down?
No. Because the way how current always takes the path of least resistance. That's basically what's happening. So when you press the switch, your MCU will read whatever value your switch is connected to. Because let's say you're using a bullet resistor, right? It has no other choice if it's open. If your circuit's open because you haven't switched your button on, your circuit's only gonna pull for 5 volts, right? It's going to read 5 volts. But if you press it down, it's going to choose the path of least resistance, and it's just going to throw it out to ground at 0. So typically, we say it's better to use a larger pull up or pull down resistor. I mean, it's all up to I guess spatial wise, or what resistor you have. But recommendation wise, just use something better than 100 ohms. That should prove well for you. I usually use 10K, 1 kilo. That's a good option. But any other questions? No? All right.
Okay, so hopefully you all have the Arduino IDE pulled up, because now we're going to start getting into that. Not, I'll let you give you all a second to get it up.
Oh, actually, show of hands. Who downloaded the new one versus the old one? Who has 2.0 downloaded right now? Raise your hand. Okay, I guess so.
Okay.
I just want to get a poll for it.
This particular one is going to go through the 2.0, but the 1.81, it should be essentially the same. It just is going to look slightly different. But let me know if you ever get confused if you're on the 1.8 version. Okay. So first things first, you open Arduino IDE. I hope you've already done that, but then the next thing that you're going to want to do is you're going to want to make a new sketch because we're going to make a new project. We're going to make a new file. So to do that, you can just go to File and click New Sketch. That is to just open something new. If you're opening the Arduino IDE for the first time, you're probably already going to have some kind of empty sketch in front of you, and you can use that if you want, but I just wanted to make sure to include this in case you want to make like something new, so you know like where you can make a new sketch. Okay, so once you have your new empty sketch, it should look like the third-ish picture that's underneath step 3. And you should be able to start coding there. That's where you're going to put in all your code. You see the void setup is already there for you, and the void loop is also already there for you. So you can just put your setup and loop things into there. If you want to save your file and give it a name, as in like not the date, which is what it's like defaults to, you can go to File and click Save As. And then it should let you name that file and save it to wherever you want. Arduino IDE 2.0 will autosave your work as you work on it. 1.8, I don't think it does, but as long as you're continuously, compiling and uploading, then you shouldn't have a problem with like missing saves. Finally, probably the most important part, to compile and verify your code, which helps check for errors, you're just going to click the teal check mark at the top left. Is anybody in 1.8 like not able to find things? Or no, we're all good? Okay, great. So that's just like the basic how to use the Arduino IDE. But next, here are some like important features of the IDE. So you have the output, which is going to be at the very bottom, and you also have your serial monitor. So the output is going to give you some information if you upload your code and there has some errors in it, or when you verify your code and it might have some errors in it, or if you upload your code and there's some kind of error with the upload, that's going to come out in the output. So if there's any like fundamental issue with your code or with the upload, then you're going to see it come out in the output. I think in 1.8 the output is also at the very bottom. However, in 1.8 the serial monitor is slightly different. So 2.0 version, the serial monitor is in the same areas where the output is. That's just going to give you all of your serial outputs. If you write serial print statements in your code, then that's where where they're going to print out when you start running your code. In the 1.8 version, there is a magnifying glass in the top right, yes, and that's going to open up a separate window. It's the same thing. It just is a separate window instead of being the little thing at the bottom there. But completely same idea. Okay. So to remember to use a serial monitor, you're going to have to put serial.begin 9600 in your setup. So just remember, don't forget to do that if you want to use a serial monitor, which you don't have to. But okay. Hopefully all of that makes sense for everybody.
Any questions? Any concerns? Any hopes? Any dreams? No. Wow. I always ask, but there's never any hopes or dreams in here. It's the major.
Bummer.
I'm trying to think of a bad professor that maybe must have had. Or not bad.
Corbin.
Someone that's obsessed with. Yeah. Do anything with Corbin?
I'm teaching 1D this quarter.
No.
Wow, that's a
Oh,
win.
You know, sometimes the
I
universe
triple
just
dub.
needs to help you. That's it.
Okay.
I never had Corbin. I had tongue. If you guys can get tongue for physics, peak professor. Like one of my best lower professors. You good?
Okay. I'll move to the next slide. So this is about uploading to your Arduino, which is another sort of thing you have to go through. So you want to make sure first that your Arduino is connected to your computer. Hopefully you've already done that. And then you're going to want to click where it says, click on the bar next to the 3 teal circles. This is in the 2.0 version. I think in the 1.8 version there is something similar. Sorry, is it okay if I look at your tablet? I think it is in tools. There's a tools up top. And then, yeah. Okay. Right, an Arduino. Right, and it should automatically connect to it. So ideally, it should be pretty easy for you to like go into the drop-down menu and find where your Arduino Uno is, because your computer should recognize it. But if it doesn't, then just there is like a little process that you can go through here to look for it. This isn't the 2.0 version though. In the 1.8 version, what you have to do is you can go to Tools, and in the drop-down, there should be a boards thing that says Arduino Uno, and you should be able to select that. But if you aren't able to, please let me know, and I can get you there.
I mean, both are good. 1.8 is definitely like much more used. We've used it forever.
Yeah.
But 2.0 is kind of nice because a lot of this stuff is automated. Like with 1.8, you have to manually save it, but with 2.0, it auto saves. Which I don't know why they didn't just add that feature, but you live in
Yeah, they had to make a whole new IDE to implement autosave.
It depends on like device, but I'm pretty sure sometimes it automatically like knows what your plan is.
Yeah, no, it should automatically know what you're connected to, but if you're using like a bootleg version, like I use an Idea Hacks, then it's not going to recognize it. So no, of the Arduino.
Oh,
because they make bootleg Arduinos because they're cheap. Okay, anyway, don't worry about that. But let me know if you can't find your board or if it's like not connected or something. Okay, I think this is just like the majority of like the Arduino technicality stuff. As long as you've gone through all the steps and you can make sure that your board is connected correctly, then you should be able to upload your code just fine. Okay, so this is checkpoint 1. This is where we actually sort of get into like making your project. Well, I call it a project. It's like a mini project. So the schematic for your button is right there for you. The schematic for the fan, it should not be that crazy. You should just be able to plug your fan into a digital pin, and then that would be the red lead into a digital pin, and the black lead into ground. And the task for this checkpoint is to construct and program a circuit that will turn your fan motor on when the button is pressed and off whenever the button is not being pressed. So you hit the button, the fan turns on, you release the button, and then the fan turns off. And I have a little snippet of some example code that you can use in order to help you make that happen. I think I want to just like go through the rest of them. Okay, so this is the first checkpoint. I want to let you guys go, but we'll just go through the rest of the checkpoints really quickly. So part 2 is going to be the same as part 1, except now you have 3 buttons. So it's the same exact idea, except instead of using a digital write pin, you're going to use an analog write pin. That's going to write high, medium, and low speeds to your fan. And you're just going to be adding 2 more buttons so that when one button is pressed, then it's the high speed, another button is pressed, it's the medium speed, the other button pressed, that's the low speed. Your code should be able to detect which button was pressed and then power the fan at that speed. And there's another little snippet of sample code. So these are the 2 main checkpoints for this project. If you want to do a little bit of bonus work, then you can implement the potentiometer. I'll let you guys look at this yourself if you're interested in doing it. But those are all the directions. They're pretty detailed, so hopefully should be intuitive.
I will say that whoever finishes the first 3 people to finish the bonus checkpoint will get a very special prize that we actually have left right now.
Ops merch.
And it's not fruit stands. It's merch.
Legit merch.
Yes, legit merch. So if you like finish it and it works, then you get something. So that's a little bit incentive. But your first 2 checkpoints also have to work.
Yeah.
For that to work. So.
Okay.
All right.
This is.
You get hacking. We're gonna start turning on the lights, right?
Well, one second. A couple of notes I want to mention. If you're like having trouble with turning your fan on, it's probably not you. It's probably just the fan. In my experience, when I was doing this project myself, I noticed that even if you power the fan like super high, sometimes you need to like give it a little flick in order to get it actually going. So just keep that in mind if you're having trouble with that. If your fan is not working at all for whatever reason, you can also do this project just with an LED, and it should work the exact same. But yeah, that is the main thing. The slides are also on the master sheet, and the quiz and the checkoff are also on the master sheet, so you should be able to go there if you want to. But you guys are allowed to start working now. Just let us know if you have any trouble.
You guys want lights on or off?
Probably on, yeah. Okay, I will stop the recording now.